I'm actually thinking of having a little soundtrack with a countdown for these moments where I'm trying to fill in the void while everybody sits down just before we start. But I would have missed the moment to start it because it is now 10:20 and you are now stuck in this room. I'm Sebastien and I'm going to chat with you about REST 3.0. I have to admit, it's just a link bait title. It's just to get you in the room, and it's obviously working really well. So that's marketing for you. Before we start, I'm taking a huge amount of time from all of you. An hour for however many people are in there, and I'm pretty sure that we could rebuild the whole of the internet software just in 1 hour with the number of man hours that I'm going to take away from you. So to give you an idea of why it's useful to come and listen to me. Useful? No, that's very arrogant. Not sure about useful, but why I'm talking about this stuff. Who am I to actually bother you with all this boring topic? I'm Serial Seb. This is my Twitter feed. If you want to comment on the talk, send me questions, chat, criticize, whatever you want, feel free to do it on Twitter because that's the only thing I really respond to. Once upon a time, I discovered the whole wonderful world of what we used to call SOA back then, with a chap called Clemens Vastas. And I've been very interested in distributed systems ever since. Now, back then, I was very much the traditional SOA guy with all those technology stacks that we now consider out of date and distasteful. But, you know, it was the thing that I really believed in back then. And then in 2004, I discovered REST, and I thought I understood REST, and then 10 years later I thought I understood REST, and we're now in 2017 and I think I'm starting to understand a few things about REST, but I'm still learning. And a little bit further down the road, for those of you that are on .NET, I built a little framework back in the days when we only had web forms called OpenRasta, which was about building resource-oriented systems. And there was nothing back then because we were still having technologies that were trying to pretend to be Windows applications developed over the web. How many of you are .NET developers? Okay, well, that's so. It was back in the days before MVC was created. It was a long time ago. And I've been wrong often enough to have something to say. Most of the stuff I teach people is because I have done and failed more often than most people have tried. I do fail a lot, but I'm okay with that. I'm in recovery. So, as I said, it's a bit of a clickbait title because I wanted to talk about what the state of HTTP technology is today and what it's looking like for API developers as we move forward. And I'm doing that because there's been a bunch of talks and a bunch of technologies and a bunch of marketing recently that have decided that REST is dead because JSON APIs that are badly done are badly done. And so obviously it's the problem with the architecture. And so people said, oh, REST is dead, we have a better thing coming. And the difficulty, of course, is that they're not talking about REST. They're talking about what we colloquially call REST, which is anyone slapping anything behind an HTTP interface with JSON, because curly braces are better than angled brackets, right? Come on, it was a good joke. Feel free to laugh, otherwise I'm going to be stopped in my track. So I called it REST 3.0 because when we're talking about REST, we need to understand what the heck we're talking about. And I've decided that there was REST 0.9. It's my scheme of naming things. The web started quite a while ago and still survives. It's the longest running distributed system in the world. Something people don't often realize. It's the only distributed system in the world that has lasted this long. And we've had a specification in '99, and we had Roy Fielding's thesis. It's a big fat document about how to define architectures. And one of them is REST. It's just what the web was designed to be. And then people decided, oh, HTTP is great because we can get through firewalls. And so we had, anyone knows who that is? Dunbox. It's Dunbox. This is a Microsoft conference back in those days where I put the one where he had his T-shirt on. Now, unfortunately, he did remove his T-shirt a little bit later on, which I'm pretty sure these days would be frowned upon in a conference. So I've left the one where he was dressed. Soap was all the things. And I was a soap guy in 2001 and 2002. And I thought, you know, WS everything was everything. And the REST that we talk about usually looks something like that. It was really in response to all those middleware vendors arriving with very complicated technologies that did very complicated stuff for very complicated customers. Except we all had to use the level of complexity that very few actually needed. So as a compensation action, people started embracing this. Very simple HTTP, try to fetch very simple data models. It would have been XML back then, but I put JSON because I don't think people can still read XML. And so we fast forward a little bit in 2009, and I remember being at speaking a lot about REST, and I was telling people it's absolutely terrible because anything that people slap over HTTP is now called REST. As long as it's JSON and as a URI, you can do as horrible as you want, it's still REST. Mostly because vendors decided that REST was a cool term to sell their products and slapped it on absolutely everything. And I think that continues to this day. But back then I thought that we needed to really fight for that name because the name was now being used in a way that didn't describe systems that I was building, and that was very frustrating. I was wrong, and we all lost, and I think I was not the only one. A lot of us in the community at that point were saying, well, you know, we tried to talk about REST, and it's just basically RPC over HTTP. That's what it is. We just do a bunch of RPC over HTTP with a bit of JSON. It's simpler than SOAP. People call it REST. Everybody's happier. And so we changed our minds a little bit. And I think it was around 2011. I think the whole community decided maybe trying to keep that term to describe what we do is not useful. So we decided to talk about Hypermedia. And Hypermedia is what we spent the last 8 years trying to get you guys to use. How many of you are using Hypermedia in some form? Okay, how many of you are not using Hypermedia? How many of you cannot raise their arms because they're hungover? Okay. Well, you know, it's a conference. You have to enjoy yourself a little bit. All the ones that raised your hand when you said you're not using Hypermedia, you're absolutely full of it. Because you all use a browser. And that's the root Hypermedia API of all. We use Hypermedia all the time. It's part of our culture. It's part of what we understand. The browser is what we understand the best because we use it all day long. First thing you do when you arrive, you log into Facebook. You look at pictures of cats. That requires Hypermedia. Without Hypermedia, no Facebook. No Facebook, no cats, no happiness. So we all use REST all the time. We use Hypermedia all the time, but we don't do it in our APIs. We do it everywhere else, but in APIs, somehow it's a different world. And some vendors will try to sell you two different frameworks, one for APIs and one for the web, even though they are exactly the same thing. So the REST 2.0 was Hypermedia circa 2011, trying to get people to say, well, you know, instead of trying to encode everything in an RPC style, maybe just try to follow links, because we're pretty sure that follow links kind of works, because that's kind of the internet people use every day. And so we're now a lot longer after that, and we are now at REST 3.0. And REST 3.0, what we're going to be talking about is all the technologies that exist today that you can use to make APIs that are significantly better than the horrible RPC crap I showed you earlier. And so if you're not interested in the current state of HTTP, media types, Hypermedia, feel free to leave the room. I will not get it against you. If you expected me to announce an amazing product that will solve all the problems, I'm sorry, I'm not Facebook. I can't do that. But we're going to talk about what we can actually do with REST today. First thing, of course, is to look at your API and wonder, is it RESTful? So there's a website for that. You can go to isitrestful.com, you type in an address, and it gives you an answer immediately. No. If you type it again, it will give you another answer. I love the smell of post in the morning, as you start smoking a cigar. Don't do it in the morning, it's sickening. It doesn't matter if your API is RESTful or not. It does not matter. No one cares. No one cares if it's Hypermedia enabled. It doesn't have a value in itself. Being RESTful doesn't have a value because you have a brand or a stamp on your product saying, you know, RESTful certified. Certified RESTful master. Although we could have made a lot of money from that, but we did not. What's important is the features that we bring, right? The important things that these properties to distributed systems provide us is a bunch of stuff that we can do with, right? That's the reason why we use stuff. So I'm going to try to use a bunch of user stories to explain the various bits that we can use today. And the biggest advantage of using RESTful systems is standard. It's stuff that we can reuse across the whole internet and not have to reinvent all the wheels all the time. Even Apple gave up on reinventing wheels for their car. They gave up the car altogether, but they did try and failed at having round wheels. Uninteresting, but just pub quiz question for you. In order to stop reinventing the wheel, I want to use my existing knowledge, tools, and libraries. And that's very important because one of the things that the web provides is that it's the same browser, the same technology that allows you to go over every single website. When you build your UI, you know that every single browser reuses the same technology that is compatible across vendors. And once you've learned something once, you can reuse it for however long that technology lasts, which these days is about 6 months. But at least whatever client you're working for, you know it's going to be the same stuff. And that makes it very different from the RPC way. What RPC provides you is each and every single API that you go to has a completely different definition of the operations it has. So for every single time you want to interact with an API that is built in an RPC where you need to know statically, in advance, out of bound, what is the way to retrieve a customer, what field I need to provide it. You need to read the documentation, write that in code, and as soon as you switch to another server, it will have a different definition. And that's not just between companies, it's within your own company. Because within your own company, each API will be controlled by the one team that has that API. Which means that we continuously have to rebuild the interfaces that we use to interact with each of those distributed systems. The difficulty with that is that we're having more and more of those services. More and more faster and faster deployments inside our businesses with various bits of functionality that keeps on being built faster and faster. And the more we create new interfaces, the more you're continuously playing catch up because you have to rebuild this stuff every single time. So HTTP solves that by providing us with a uniform interface. That's the beauty of HTTP. I will access a customer resource exactly in the same way with the same identifier structure, same methods being supported, and they are standard everywhere. That means I can write the code once and be done. I never have to think about it again. The uniform interface allows a lot of tooling. And again, none of this is new, right? I'm just giving you a bit of background to make sure everybody is understanding where I come from on this stuff. We have dev tools like these. You can interact because of the standard interface and the fact that we use standards. You can use Chrome DevTools to debug your services that retrieve customer records. And it sounds like something completely normal and natural, but if you go back in 2000, try to interact with a SOAP service with some browser development tools. It was just not possible. You would see the XML, but that's the only thing you would see, whereas now, because the system is completely self-descriptive, you know exactly what's going on. And you already know how to do it with web pages, and you do it with your APIs exactly in the same way. If you break that standard interface by reinventing something completely new, well, you have to reinvent dev tools completely new. And these things cost a lot of money to build. How many of you have built your own debugging visualization tools for your services? No one? That's exactly why, because no one has the time or the money, right? But Google does. So if we can piggyback on what they do, it's pretty good. The problem, of course, is that when we're on the web, you know to type in a web page and we start clicking around, and that's how you get to the picture of the latest picture of the babies your neighbors just had. cats, dogs, or actual human babies, doesn't matter, as long as it's cute, right? But we know how to go from the entry point and then follow the links to get to the information we want. So one of the technologies that we can use now, and I'm using an example of my Restflix system, a new company that is very innovative and is going to provide a RESTful interface to stream movies, because apparently it's a really good new technology that people may do one day, watch movies on the internet. So it's called Restflix, and this is called the Home Documents. It's a new RFC that I believe Mark Nottingham is writing. This is a one location. When you arrive on any domain, you type it in your web framework or web library of choice, and it will retrieve automatically a bunch of information about the API. And it will say, for example, that if you want to access a movie, you have a resource that is at movies, and then a little squiggly template there where you can fetch it. You can fetch a movie, and we know it's a movie because we use what is called a schema. We can say that there is a standard thing called a movie, and everybody agrees on that definition. It's already documented. If you go to that URI, you will actually get the documentation with all the properties and what they mean and how they've been categorized, and that's already been built for you, so you don't have to reinvent a whole media type with your own custom serialization. It's already done for you. This is actually real data. And I can say that if you follow this link with a number for movie ID, you will get a movie. And so all those schemas have already been built for us. There's nothing to do. It's already there. How many of you write documentation for your APIs? How many of you wish that you didn't have to write the documentation for your API? Okay, well, that's another good reason to reuse schemas that have been built by people. Now, schema.org is actually implemented by search engines, by Google. This stuff is live, this stuff exists, this stuff is in use. If you go to schema.org, you will even see an estimate of how many websites are actually using each of the data types. So not only do you not write the documentation, you can build the code only once, and you can know if other people are actually using this stuff or not. I think it's pretty cool. So if you were to write some code, that could be most languages now, because they all more or less look the same in the object-oriented world. I could write once a get link to that takes a relationship, saying I want a movie, and it takes a parameter of 28. And this is code I could write once and never touch again. And if you're a little bit lucky, someone else already wrote that code, so you just pull in a package in your package manager of choice, and if it manages to pull packages, which package managers don't always manage, then you get that for free. And that's technology that exists today. And if that movie is not available because I'm trying to buy it and I'm running out of money, error codes can also be serialized with a standard that exists today. That's the problem format. Problem format is a way for you to return your 500 and a body that everybody can understand over the internet, so that your code doesn't have to manage errors on its own. It can reuse a standard. And again, I'm going to hammer the same stuff over and over again. It's a standard. Someone else wrote the documentation. Someone else wrote the code. You don't have to care about it. And something will throw a nice exception with all this information for you, so you don't have to ever think about it again. And it would look something like that. You can do your little code, and it would throw an exception for languages where things use structure exception handling. And you can handle all this code in a standard way without ever having to think about it. So not only are we self-descriptive, we have schemas that are reusable, and problems have been standardized so that we can communicate them across all of our services in the business and across businesses. The other parts that we do on HTTP is layering. Right? It's part of REST. It's a little bit like what we had with DevTools, but extended to the architecture. Each single section of a request going all the way to the server and all the way back is going through a bunch of layers. And each layer is capable of reading the information that goes through, because HTTP is self-descriptive. I know which resource is being called. I know what schema is in it because I have a media type, I have the schema.org, I have all this stuff. And without understanding anything about your domain, I can write generic code that can do a lot of interesting stuff. And so we already know all this stuff because we use CDNs, we use reverse proxies. Some people still use proxies, especially the bankers. I don't know why they love their proxies so much, but they do. And all this stuff is provided because of that standard interface, because we use standards, because we don't just use marketing tools that vendors are shoving down your throat. We have 20 years worth of implementation behind HTTP. And you can build your own. And that's the beauty of it. You can build your own. No one does it. But building little systems that communicate with one another is allowing you to have very generic applications. Anyone is using AWS API Gateway, for example? Okay, so for the people that survived using API Gateway, because it's a little bit fidgety, it's a reverse proxy. It receives your connection, it implements HTTP2 for you so you don't have to do anything, and then it can dispatch and route based on different URIs or URI structures to different of your services, so you don't have to do anything. And it can only do that because we use a standard interface. If we didn't use standards, it wouldn't work. And you can build that all the way to your own code. For example, here it's a middleware. Most systems have one, a little bit like that. All the way into code, you can build orthogonal concerns, and a lot of things are orthogonal by definition, by just having a layering that goes down all the way down to the code. And most frameworks that do web implement something like that. For example, right now I'm building a part of my system where I'm billing people. And the billing engine is receiving the HTTP connections, retransmitting it to other services, and charging you based on your usage. The interesting thing is it absolutely has no knowledge of the domain that the services behind it implement. It just sees stuff going in, stuff going out, and it just matches with little strings, and it charges people automatically without ever implementing anything that is specific. So once I've built it once, I can reuse it across all my systems. And charge more. And charging more makes more money makes Sebastien more happy. The next thing, of course, that we want in REST, and yeah, just checking that we're doing good for time because I have lots of slides, is to be able to evolve systems. It's all nice to have nice systems, are self-descriptive, etc. But if I have to systematically rewrite everything like I did in RPC, I'm losing a lot of the benefits. So in order to allow independent development of client and server applications, I really don't want to have to get all the clients for my API rebuilt whenever I make a change. Hence, don't use versioning. I want to have independent clients for multiple languages and platforms. That was not a problem 10 years ago, but we more and more have multiple languages inside our infrastructure. Right? How many of you have more than one language in your code base? More than 2? More than 3? There you go. There's a lot of, you take TypeScript, JavaScript, C#, Dart, I don't know. Does that still exist, Dart? I don't know. We have more and more clients because we have more and more systems and we have more and more services. And so we need to be able to support multiple clients built into different languages by different teams. We don't have the capacity anymore to build a server and the client API in sync all the time because it would be much more work. So we allow the server and the client to evolve independently so that you don't really have to talk to the server guys too much. And you can just keep on building your stuff, and the client guys build their stuff, the server guys build their stuff, and because they use standards, normally they should be able to integrate well. But that's why you have tests, right? And I want to evolve my server application without breaking my customers, because you don't break people. Just good idea. If people pay you, you don't break them, right? So stop using versioning. But I've got another talk about that. You can go and check it on the internet. So part of being able to evolve all this stuff is to follow the links. That's the Hypermedia part of REST. I want to make sure that you don't have to implement all the URI templates in a documentation, code that into your little client, and hope that this will never change. Because tracking which link goes where is hard. How many of you keep a list of redirects that your website does? Redirect lists whenever you change anything. No one at all? One person? That's why we have so many 404s, because it's unmanageable. This stuff is unmanageable, and no one does it. Even Microsoft doesn't manage to keep their documentation pages in sync. Why do we do it for APIs? I have no idea, because someone thought that publishing a list of links with URI templates was a good way to document APIs. And then they call it Hypermedia, which is hilarious. But I have an example there where you have the Redflix 1.0, it has some URIs, and then I release Redflix 2.0, I break everybody, my customers are very unhappy. And you can see how good my drawing skills are. That's why I'm a developer, not a graphic person. Graphic person? Designer? I don't know. So I want to discover all those links dynamically, and the way we do that on the web is to have a relationship between things, right? This is, if you want to sound smart, it's called a directed graph. If you want to, that's to sound smart to your friends. If you want to understand what it is, well, I've got a thing like a movie, and I've got a thing like a movie editor. How do I relate the two? Right? I've got a woman with weird yellow hair that's always very angry, and there's me, and the relationship between the angry woman and me is mother. Right? From me to the angry woman is mother. That's the relationship that we have together. When we're on the web, we have those relationships all the time. When we click around and you want to go to the profile of Jenny, which just had a new dog, I have a link and I know that it's the page of Jenny because that's what's written on the little title. That's the relationship for humans. And for machines, we use the relationships exactly in the same way by using keywords, editor, or using URIs, a little bit like that. And those are links you can follow so that your client can be more generic, more reused across APIs. You don't have to rebuild the same stuff all the time. For example, that's HAL, Hypermedia Application Language. That's someone called Mike Kelly worked on a long time ago, which is now a standard. And this allows me to define in my API that I have the terminator, and it has a self link, which is a self-referential link. It just means this is my URI, and it's movie/terminator. And it has an editor to edit the details of the movie in case you want to change the description or you want to change the date of birth or death of Schwarzenegger. It might happen at some point. It's not that young anymore. Yeah, I'm not wishing his death, that's not what I'm saying. So I've got the link editor, and that gives me the next link. So instead of coding in my codes that I want to go to the next web page with that URI, I can just say generically, I know it's a resource, I know it's supposed an editor kind of link, and I want to be able to show a little button in my UI that says editor, and it will just follow magically. So I can write the logic once for any kind of links, and it will always show me all the buttons, which I think is pretty cool. We can do the same thing in link headers. It's going to become more important with some of the features I'm going to show you in a little while. And again, we have the same thing. We have the relationship with a little rel equal and a link. And this is called the web linking specification. I think I wrote it wrong. It's RFC 5988. That allows you to provide links, but are not even tied up to JSON. You can use the same header with HTML, you can use the same header with XML, you can use same header with whatever new binary protocol will come out next. And this is, for example, my custom version of HTML called HTML wobble, 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 which means that it's a wobbly specification. That was a weird joke, I'll give you that. I'll have to rework that one. So we can discover all these links dynamically with all those technologies that are standard, and there's probably already a library in all your favorite languages to do linking for you, so you never have to think about it again. The next step, of course, is once we have links, what else do we have on the web? To interact with servers. I can click on stuff, and what else can I do? Anyone? Are you all dead or bored or what is it? Well, yes, more than that. If I want to buy something, what usually happens? Okay, that's at the, let's just think about HTML pages, right? Let's just say I'm on Amazon and I want to click on buy. What is it going to do at some point? Redirect to what? It's going to have a page and it's going to start asking me for information, like my credit card number. Pretty useful to buy stuff, right? So we have forms. I thought that was obvious, but maybe not. Okay. We have links and we have forms, right? Links is to navigate and forms is to send data. When the server tells us, oh, I need this stuff now for you to get your, I don't know, your picture frame for cats. I don't know why I'm about cats today. It's just a thing. So we can do this with APIs also using standards, just like we have HTML forms and everybody knows about them and you interact with them everywhere the same way. We can do the same thing with JSON APIs. This is a format called Siren. A lot of those Hypermedia formats all support some form of forms. And Siren here will define that I can order the movie Terminator and I will want to receive an application JSON format. So I want to receive a post at that URI with a hidden field, because that is very secure. So you can't buy a movie by changing the value, but we'll just pretend that my users are just very honest. And an order number which is 42. So what the generic client would do at that point is to say, well, I just want the order movie form and I don't really care how you get there. And it will see that there's a bunch of fields. It put the fields into a JSON, and the library that will implement that will have no knowledge of what the RESTflix is doing, because it's built once and I never have to think about it again. I keep on repeating myself a little bit. But that's why we use those technologies. So we have links, we have forms, and that's the Hypermedia part. And this is where we get to the scaling part of things. And I've got 9 minutes. Perfect. In order to scale my application horizontally, I want my service to function autonomously and independently. And we've had that concept of autonomous components for quite a while. What do we get? Well, those autonomous components these days are called microservices. Who's heard about microservices before? Okay, who thinks it's new? Good, good. People are learning. That's very good. So it's not really microservices in the RESTful world, because we kind of have this already, right? We've got micro resources. I don't know. I think they're kind of just resources, right? It's just we already have that notion. Can someone give me a definition of what a resource is? Someone try. No one. All right. God, you're a hard crowd. Even the Danes are easier. You know, one time I got everybody to dance in Sweden, so I know you're capable of more than this. Resources are anything that has a URI. Anything that you can individually access with one URI is a resource. There is nothing that prevents you building systems that have this nice, symmetric decoupling where each of your microservices is just a resource working individually. A lot of the serverless approach is actually building on that idea. And they are nice, cohesive units that you can probably deploy independently. Try it, it's fun. But to be able to deploy each of those microservices, each of those resources independently, well, you'll bloody need linking, because this stuff is going to move around, because you want to be able to publish these very quickly. We won't have the time, but caching is pretty important on the web, because that's how we make systems much more efficient. And because every single of those resources have its own URI, it has its own caching instructions, it has its own cache invalidation, all this stuff is generic, you build it once and you've got caching for free everywhere. Because if you want to implement caching correctly, it kind of looks like this. And you really don't want to be implementing this stuff on your own. So for those of you that think that GraphQL is solving the world, there's a reason they've not built caching in. Yet. But I'm sure some vendor will fill that hole at some point. But we already have that on the web, the technology exists, it's already deployed, it's already available, and you don't even have to pay for it because most of it is open source. But hey, you build it the way you want. So we can control the cache, we don't have the time to go over there, I don't want to talk about this right now. We're just going to move to the last part that people moan about a lot is efficiency. HTTP was not designed to be a fast protocol originally. It was designed to be flexible, it was designed to scale well, it was not designed to be efficient. Hence the fact that it's based on text, it's based on the same format as SMTP for its messaging format, etc., etc. But that was 20 years ago. So one of the things that some vendors will tell you is, oh yes, but I just want to retrieve some of the field, and I want to retrieve all the children, and I want to expand just those children. And so now you have, for a movie list, do I want the first 10? Do I want to have each of the movies being in line so that I only do one round trip? Because apparently the round trip is very important for people. Because HTTP was inefficient, if you try to retrieve the movie list, then you would get the response, and then you would have to go back and download each of the other movies, and you end up with an N+1 problem. You end up downloading a huge amount of data, it's very slow, and it doesn't work well. Now we have better technology for doing this. We can do preloading. And this stuff is already implemented in the browser, by the way. So if you want to build it in your API, and you're not running inside the browser, it will take you 5 minutes, but if you're in the browser, it's for free, right? I can go and retrieve my list of movies, and before I even get to the list of movies, I already have the headers telling me whether there's Terminator, Terminator 2, and I've not included the other ones because they're not as good. And it looks something like that, and that's the beauty of what some people call transclusions. To be able to have caching working, I want my movie list to be fixed. I don't want to have variants. I don't want to have sometimes the movie included and sometimes not the movie included. Because the more variants I have on those resources, the less cache hits I will manage. And so just to be more efficient on a request, I lose the capacity to cache better. But with preloading, I can start receiving the headers, and before I even start downloading the JSON document, I can start issuing a whole bunch of requests for every single one of the children, because the headers told me to. And so before I even get to the end of the movie list, my cache locally in my API or in my browser already has the 10 movies that go in it. And that would be terrible if the old HTTP was still having a serialized request model. In HTTP 1, how many connections do I get on the server? In theory? In HTTP 1.1? 6. But it's implemented 6. Originally the spec said 3, then people realized maybe we need 6. Why do we have 6? Because there was no way to multiplex requests. The request you did in HTTP 1 looked like this. I do the first request, I need to wait until the response has finished before I can do the next request. And so people connected to 6 different connections, so you could have 6 requests concurrently. But that was still very inefficient. HTTP 1.1 introduced pipelining so that I could do 6 requests and then get 6 responses. It's poorly implemented everywhere because the spec was badly written. Some browsers like Opera on mobile do that, but the majority of them don't really do it. And that's where HTTP 2 is now solving all those problems. You never have to think about it again. HTTP 2 allows you, as soon as you receive your first request and you start receiving the headers, you can go and retrieve all of them, and they will arrive in whatever order, but by the time you implement your code, you will go back to your HTTP client to retrieve the terminator. It's already in the cache. Your code looks like it doesn't care if it's cached or not, because it just does a request like you used to, but it's actually already in the cache, so you never have a round trip, you never go back to the server. And I can download as many things as I want, while preserving the HTTP caching capacity, while preserving every resource having its own identifier, and having complete control over my cache. That's available today. That's HTTP 2. The round trip problem does not exist anymore. Anyone that wants to solve the difficult round trip problem is solving a problem that has been solved already. Hence, marketing is really good. But there you go. And on top of it, even the inefficiencies in HTTP have been changed. We now have a binary format. The headers have been compressed. They have a little dictionary. Everything's compressed. Everything's very fast. The headers are very small. So the cost of doing additional requests has gone down. So the fact that you have to go and do 12 requests to get the data you want, between preloading and binary headers and the compression, no one should care anymore. It's a solved problem. It's a solved problem. So how much better is it? That's actually something that was released yesterday, I think. The BBC has switched to HTTP 2 for everything. And they get, for the fastest connections, they only get a couple of % of speed up, but the more unreliable and the slower the link is, for example, mobile applications, because mobile networks are still terrible, and in the UK they're getting worse, because it's the UK. I don't know, I think they must have been using European network gear, and they have to replace it now or something, I don't know. But you can see they can get 35% up, and that's just for web pages. If you're looking at transclusions and APIs, you're really looking at a huge, huge, huge fasten up of getting your data. I'm going to skip that. And we have the future coming with Quick, which is the successor to HTTP2. So we're not stopping where we are now. It continues being improved by people that have much deeper pockets than you. And it's still standard. Every single investment you do today in RESTful systems has all these features, and it will continue getting better. We're going to have more and more generic clients. We have even more generic formats like Hydra and JSON LD, which I'll be very happy to talk to you about at the pub if we go there at some point, not now, this evening. And for those of you that wondered if it was dead or not, this is going to be re-released with a completely new version that implements a lot of this stuff I showed you around February or March. So that was my REST 3.0 talk. I'm Serial Seb if you want to hashtag this a REST3. If you want to review the slides and the content and some videos, you have this URI at the top. And my Twitter if you want to talk to me. Otherwise, thank you very much. And I apologize for leaving you 45 seconds late.